In the third part of the presentation, we are going to look at the standard normal probability distribution, an example from that. We're going to deal with the PEP zone motor oil example again. And just to remind ourselves that the key parameters, the key values in this example was a mean of 15 gallons there, so mu is equal to 15, and a standard deviation of 6 gallons. So that's our sort of starting point. In the last example, we were asked for the probability of a stock out, where a stock out was 20. If when x gets greater than 20, the demand for x gets greater than 20. X is the demand. When x is greater than 20, what's the probability of that? So let's go back down here now. This is from the last presentation, so I'm just going to skip down there again. So essentially what we're going to be asked is, we have found x equal to 20 to be, the probability of x equal to 20, greater than 20, sorry, is equal to this here, 0.2033. Now, what we're going to do here is, for some specified level of probability, we're going to mark in that zone there. What is the value of x? So what we're going to do is have this as 5%, 0.05. So we're going to start with the desired probability and then work backwards and find x, which is the opposite case. We started with 20 and ended up finding 0.2033. In this case, we're going to start with 0.05 and work back and find x. So let's actually formally look at the question here now. So if the manager of PEP zone wants the probability of a stock out to be no more than 0.05, what should the reorder point be? So that's the sort of verbalization of the question we're about to ask. Okay, 5% being 0.05. So what do? Well, what we're going to do here is, in the last question we started off with finding the z-score, and in this case that's what we're going to do as well. So we have an area here. We're going to start off with this area of 0.05, and what we're going to do is first off find the corresponding z-score that would give us 0.05, such that the probability of z being greater than this particular z-score we're going to find, capital Z and a small z, capital Z being the name, small z being some value, 0.05, like that. So what we're going to do here is go back to the tables, and we're going to try and find out the value that gets us as close as we can to 5%. Now, if you're sort of skimmed through the tables like this, you get two values together, 0.0505 and 0.495. Okay. Now, roughly the average of those two numbers. What values did they correspond to? Well, 1.6 and 0.04. So let's write that down here at the bottom, 1.64. And then 1.6 and 0.05, that will give us 1.65. Okay. So what we're asked to do is find the z value that gives a cutoff of cuts off an area of 0.05 in the right tail, the upper tail of the standard normal distribution. We don't have a precise figure here. 1.64 is just a little bit too, gives us a value, an area that's just a little bit too large. 1.65 just gives us an area that's just a little bit too small. What we're going to do here is just get the average of the two. That is one approach. And so what we're going to do here is we're going to use it as the average of these two numbers. Now this is a sort of special case. So this is halfway between 1.64 and 1.65. So we're going to use, where are we going there? 1.65. I'm just going a bit out of shot there. So, that's the z-score we're going to use, is 1.645. Okay. Now, this is the standardization formula here from before. X minus mu all over sigma, that gives us a value of 1.645. Okay. Now, just remember x is 15, or sorry, mu is 15, and sigma is 6. Okay. So this would be x minus 15 all over 6 is equal to 1.645. Okay, so what we're going to do is rearrange all the numbers here. And essentially what we get up, if we arrange this here, we would get x is equal to 15 plus 1.645 times 6. So that equation here is just a rearrangement of this equation here. Okay, and it's pretty simple to sort of calculate x there now. X is equal to 24.87. Okay, and you can round it up to 25. So a reorder point of 25 gallons will place the probability of a stock out during lead time to be just around 5%, and in fact 0.05%. Just slightly less than 0.05%. By the way, just as a quick remark, if you decided to go with instead, if you didn't feel comfortable with this yet, and you went for 1.64 or 1.65, you would have get the same sort of value, and you would have rounded it to 25 more or less anyway. So if you weren't too happy with 1.645, or you just felt that's a little bit alien, just sort of stick to what you know. You can just pick one number of the other, and you would have got a number more or less close enough to 25 anyway, so that the rounding error wouldn't have made much difference. Alright, that ends the presentation.